We're going to deal with reading gigantic numbers here, up to 7 digits. Here's a 7-digit number. In order to be able to read it out, it's a really good idea to put commas in it first of all. You start on this side over here and you count back 3 digits, put your first comma in here, and then you count back 3 digits again. The reason for that is it makes it easier to chunk the number into parts and easier to read out. Your first 3 digits from the right are your hundreds, your tens and your units. And we'll go into a bit more detail about how that's broken down in a moment on the next few slides. Your next 3 digits tell you how many thousands there are altogether in the number. First one on the right there is your just simple individual thousands digits, if it lets me write. This is your tens of thousands. This is your hundreds of thousands. So in this particular example, you've got 794 thousands altogether. Your next column is called your million. Now, millions are basically 1,000 thousands. It just gets a bit of a tongue twister to say 1,000 thousands and then go on to measure your other, or to mention your other thousands. So that's why they separate this out into a separate column and give it a different name. So a million is just 1,000 thousands. So to say this number, we would say 6 million, take a breath where the comma is, 794,000, and then a breath where the comma is, and 321. If we start with a 4-digit number, if you just have this element of it, you would say 4,321. Moving on to a 5-digit number, we have this one, you would say 94,321. Moving on to a 6-digit number, you would say 794,321. And then moving on to that final number, you would have 6 million, take the breath, 794,000, take the breath, 321. But what do all these columns actually mean? Okay, let's start with this little units column down here. Okay, here's a unit, very tiny, all by itself. If we move on, then we have a 10. So here's our unit, here's our 10. And the relationship between these is that the 10 is 10 times bigger than the unit. If we move on, the next column along is 100. So we have units, tens, hundreds. You need 10 units to make a 10. You need 10 tens to make 100. And that pattern continues all the way through all of the different columns. Moving on again, we've got a great big thousands. So here's our units, tens, hundreds, and those individual thousands. You need 10 units to make a 10. You need 10 tens to make 100, sorry. You need 10 hundreds to make 1,000. Now I'd like to go on and show you the next screen with tens of thousands, but I haven't got enough of these red blocks here to be able to do that. So I've had to do a little bit of a drawing to help you. So everything gets a little bit titchier now. On this drawing here, here's our titchy little unit. 10 of those make a 10. 10 tens make 100. 10 hundreds make 1,000. That was the red block that you just saw. If we were to stack up 10 of those, you would get 10 thousands. And if we were to put 10 of these 10,000 side by side, you would get 100,000. I can't even contemplate doing a million, but basically a million would be 10 of these stacked up one behind the other, and that would go into this column here. So all the way through, every time you move one column to the left, things times by 10 get 10 times bigger. And that's why place value means that the value of each digit depends upon which place it is in. A number 1 in this column over here is worth a lot more than a number 1 in that column over there. Right, moving on again. If we have this kind of number here, this number 1,237,493, you can see how this would be built up from the individual building blocks. The 3 would be 3 of these. The 9 means 90, which is 9 lots of 10. The 4 means 400, which is 4 of those 100 blocks. The 7 is 7 of those individual thousands. The 3 means 3 lots of 10,000, so it's actually 30,000. The 2 means 2 lots of 100,000, and the 1 means 1 lot of 1,000,000, which is, of course, is 1,000 thousands. Moving on again, so place value, remember, the place of the digit tells you the value of it. So here, units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, and millions. To say this number out loud, we'd say 1,234,567. If you were asked which was the most valuable digit here, it would be tempting to say the 7 because it appears to be larger than any of the other digits, but this is the digit that is worth the most because it's in the millions column. It doesn't matter that it's just a 1, it's worth 1 of those millions rather than 7 of those units.